All right, good afternoon, everybody. My name is John Morello. I'm the CTO for Twistlock. We're a company that's been around for a couple of years, and really the fundamental premise of Twistlock is we're trying to help customers leverage some of the capabilities of containers to improve the security of the applications they run within the containers. If you guys have seen the press and analysts and so forth over the past couple of years, well, it tends to be a little bit of a noise, I guess, about container security, there are gaps in container security and so forth. And of course, like any new technology, there's different threats and risks that you have to address. But we fundamentally believe that containers are actually a real opportunity for a security company to change some of the fundamental concepts and fundamental approaches that people have to do with security in a way that's very positive and beneficial. And so what I'm going to talk with you guys about today is really what those changes are, what that looks like, and actually show you a little bit about how we do that within Twistlock as an example of how you can leverage that in other areas and other products as well. So this whole trend really started with this notion of DevOps, and I guess the inflection point we saw here was as organizations adopt these agile development processes in which they're going to be no longer just simply building an application in development and then handing it off to somebody in operations to deploy, but instead those teams are working together very closely, and the same teams that are operating the app are the ones that are deploying the application. The lines that have sort of segmented out, like what was pre-production, what was test, what was development versus the security team's responsibility, have really been blurred a lot. So in the old world security model, you might think of if I'm building let's say a WordPress application, as a developer, I would sit down with my security team and describe the way that application would work, right? I would tell them this front-end virtual machine, runs this version of Apache, it writes to this file path on this database, which runs on this IP address and so forth. And if you had a security team that was really on the ball, they would go to a few different tools to configure some protections for that application, right? They would go to a host-based security tool and set up some IP tables rules. Maybe they go to some sort of IDS or IPS and configure what processes or files should be written to and so forth. But invariably, that application changes over time, right? And as that application changes, the rules that you've created rot, basically, right? So if I configure my rules to protect the traffic to this particular IP address or only allow this specific checksum of HTTPD, as soon as my application is revisioned, those rules are no longer applicable. And so what most organizations, unfortunately, end up doing is sort of throwing up their hands and doing a very perimeterized approach to security, something that's not very application-centric, where the security is really at the edge of the network, not specific to the individual application. So you're not going to have a protection that's specifically for WordPress. Maybe you've got some sort of border firewall that only allows 80 and 443 into those particular IPs, but not much beyond that. And we really feel like with containers, you have the opportunity to really fundamentally change that approach. That traditional security model is really all based around the idea of some kind of blacklist or block list that you're going to have from a security model standpoint, right? You're going to have a firewall that says, prevent access to these ports, or you're going to have some sort of host-based anti-malware or IDS technology that is specifically looking for some type of threat that's known about and stopping that threat from being exposed to your application. And while that, in a sort of an isolated individual model, while that can be effective, the problem that really causes at scale is that you don't have the ability, when you think about containers, to do the amount of manual effort that's required to keep those rules fresh, right? And again, if my WordPress environment, I'm building that application, I'm deploying some virtual machine for that, I might not touch that application again for 6 months, right? And when I do, I might not change the VMs. I'm probably just going to SSH to them or make an RDP session to them and upgrade the version of whatever software I've deployed there. But fundamentally, the VM might still be the same and other aspects of the stack might still be the same. With containers, of course, that notion is very different, right? I'm probably going to be deploying that application a lot more frequently. Maybe I'm going to update it every week or even every day or multiple times per day. And so you cannot have that model in which you're assuming that there's going to be some sort of direct interaction between the development team and the security team and how my app works and what's going to happen there. And so you really not only have this opportunity to improve security, but you also have really like almost the requirement that you use tooling and you take an approach, a methodology that's very container oriented, that understands the ephemeral nature of containers, that understands the frequency of how often they're being updated, and understands the fact that responsibility is now a lot more in the hands of the developer than it historically has been. So a lot of times organizations will look at that and say, here's some things that are sort of like downsides with containers. But I think what we really look at is that there's really an opportunity here to improve the overall defense of the applications as you put them into containers. And the reason why there's this opportunity is there's a few fundamental characteristics of containers and the way that containers work that you can leverage from a security standpoint to improve your overall security posture through greater degrees of automation and machine learning that you can apply to build those application-centric policies. So one of the first examples of these characteristics is that the fact that containers are very declarative. If you think back to like a virtual machine, if I were to give you a virtual hard disk, a VMDK file, for example, not only is that VMDK very large, but it's basically opaque, right? Like I don't have an easy way to look at that VMDK file and deterministically understand exactly what the app should do, right? It's a full OS, it's got agents, it's got various other software inside of it, it's got my own software inside of it, and it probably has some data intermingled in there as well. So it's really hard to understand exactly what it should do. Containers, on the other hand, of course, containers are built from a Docker file. It's relatively easy to be able to parse an image that you're going to run into a container and understand what that should do. Your typical image is going to have probably some entry point like in a init script or something that you can parse and you can understand what processes are going to run within it. That init script might call multiple things that are going to happen before it sort of finally launches the container. So you can crawl through that entire launch process and really understand what the application should be doing much more thoroughly. But critically, you're able to do that without forcing the developer to create an additional artifact. There's been a lot of attempts at this sort of model, sort of a declarative security model in the past, but almost all of those attempts had a common point of failure, which was you required the developer to create some kind of security manifest that described how their application worked. Everybody, loves to make jokes about lazy developers, so I won't try to do that with you guys. But, I think you've all seen, if you ask a developer or, all of you who are developers for that matter, if you're going to have to do additional work to get your application deployed, people are inclined to not do it or to do it in such a way that it's so wide open that you don't really get the benefit of this kind of application-centric approach anyway. So the fact that they're declarative is important, but I think even more important is the fact that they're declarative in a way that's very in line with the overall flow and the overall way that you're using those applications. The second aspect that's really important is the minimalistic aspect of containers and I guess the images that they originate from. Again, in contrast to that traditional model where you had a virtual machine and it was very big and very opaque, containers are built from an image and typically images are very small, at least very small relative to, to what a virtual machine would look like. And that allows us from a security standpoint to be much more precise about understanding exactly what that image should do and to be able to understand the nature of how the application is built. Because instead of having to crawl through 20 gigs of a VMDK file or something, you can look at a few hundred megs maybe worth of an image that you're running into a container and really have a much more thorough and precise understanding of what that image should be doing when you deploy it and run it inside of a container. So that minimalistic aspect is also really important too, because it allows you to be able to do this kind of prediction about what the container should do at a much greater level of speed and without the sort of performance overhead you would if you're talking about gigantic sort of VM files that you would deal with. And the final one, and this one is really also very critical, is the notion of immutability. The fact that the containers that you're going to run are not going to change during their life cycle. And think about that in contrast to a virtual machine. Again, back to that WordPress example that I gave. If I deploy a VM that's running my WordPress app, and I come out with version 2 of my app, chances are somebody's going to SSH to it or have some, Puppet script or something that's going to go to that and is going to upgrade the application but preserve the rest of the VM, right? So the VM over the course of its life cycle is going to change. It won't be running the same binaries and the same configuration today that it did yesterday or that it will tomorrow. And from a security standpoint, that means it's really hard to have a deterministic baseline that you can look at and say, if there is activity that's different than what that baseline predicted, that there's something anomalous that's occurring there. So the fact that those containers are very declarative in nature, that we can learn what they should do, that you can learn about them relatively quickly because they're minimalistic, and because that minimalistic knowledge and that declarative knowledge is not going to change over time, allows us as a security company, or anybody as a security company really, to be able to do some things that used to be hard and to make those things a lot easier than they used to be. So we have this notion of security with DevOps agility, but really what the meaning of that phrase is instead of you having to have that model where some human being is going to describe to somebody else how their application works. Again, it listens on this port, it talks to this backend database, it does these different things. Software can do that learning for you automatically. So in other words, in that WordPress environment, instead of you having to go and tell the security team, my backend is, running MySQL and it listens on this port and it expects to receive traffic from this front-end virtual machine, that can be learned dynamically as you build your application. And even more interestingly is because those images are durable throughout their life cycle. The same image that I build in my development environment, it's the same image I test, is the same image that I deploy in production, means that I'm able to create that model and use that model across the entire life cycle of the application and know that what I see in one part of it should be what I see in the same other part. So we can begin the learning about your application literally the very first time that we see it, which might be as part of the Jenkins build that you're using to generate that application in the first place. So again, the idea is instead of there having to be this manual overhead, a lot of this work that goes into saying like how my application behaves, you can literally begin building that model, that list that says, here's what my application does, all the way at the very beginning of the life cycle of that application. And that's a really big fundamental difference between that old world security, which again is very manually intensive, very prone to sort of that rule rot scenario, and really is not effective at providing something that's application centric, with what you're able to do with containers in which you can apply those characteristics to really improve the automation, the scalability, and the efficiency of building application centric rules. So what I want to show you guys is just a little bit about what does that actually look like for us. So I'm going to show you a few examples of what we call a model within Twistlock. And the models that we create are basically a four-dimensional description of everything that a given image should be doing at runtime based on static analysis of the image and machine learning that we do as the image is deployed and actually running in production. So what you can see here, what we're looking at right now is what we call our radar view, which is a dynamically generated network chart that's overlaid with vulnerability and threat data that shows all the communication flows, both north-south and east-west of the Kubernetes Sock Shop app that I've deployed in this environment. But what I want to do is to kind of drill down on that further and show you what it looks like if we look at a particular image. So let's look at one that everybody's probably pretty familiar with, which is Mongo. This image that I have, this model that I've created for this image, is something that we've done completely autonomously. There was no rule, there was no human being that had to be involved with this. No one had to sit down and say, these are the rules that I want to enforce. Nobody had to like deploy the app and like click a learn now button and stop learning button and so forth and sort of commit something. This is done dynamically and starts at the very beginning of that CI process. And I want you to note that the image or the model that we have here is correlated to the specific digest for this image. And the reason that's important is every time you build a new image, you get a security policy, a model that's created specifically for the build that you're doing. So if you're making minor changes, maybe you're upgrading like a sub-minor version of Apache or some other component in your image, you're going to have a security model that's specific to that version, and those security models can operate in parallel. You might have like 3 different versions of your app that are all running as you do some sort of A/B testing. You're able to still have 3 different security models, one that's correlated to each one of those versions of the application that you have running at that point in time. And you're able to do that without any human interaction required. So that's what the digest ID here means. I want you to note that we're able to find out and understand the process that runs here. We see the path of it, but importantly, we also are able to checksum that process and understand, like, not only is this particular process that should run, but here's the checksum of it. So we can see if there's any changes to the binary, if somebody overwrites the binary or modifies it in some way. From a networking standpoint, we can learn both from a static standpoint where it's listening, but also behavioral bidirectional connectivity. For example, like what sort of inbound ports does it listen on beyond what it might be doing based on the Docker file? What are its outbound port communications? Like, does this talk just over, MySQL, like 3306 to some backend, or does it make calls for, for DNS lookups or to talk to a Redis server or something like that? From a file system standpoint, we understand what files are being written to what paths, what types of files those are, so that we can look for anomalies based on that activity. And what this model allows us to do is, throughout the entire life cycle of this Mongo container, I should say of any container that runs this Mongo image, we're looking for anomalies relative to the model. And those anomalies could be across any of those dimensions, process, network, file system, system call, such that if somebody runs Mongo and they do something that's traditionally really hard to detect in a kind of an old world security model. For example, I might have an IP table rule that says I'm going to allow traffic to port, 3306 or 27017 or whatever it is to this host. But it's really hard to say that I only want this specific version of this specific process to be the only thing that can bind to that socket and can receive traffic there. Whereas that's actually a really easy thing to do when you have this automation. Because of those container characteristics, we can understand that not only should Mongo be listening there, but it's that specific checksum of Mongo that should be listening on that port. And if there's anything else that listens there, even if it's called MongoD, we know that it's not the same thing because the checksum of it's no longer correlated to what we see in the model. And really the idea with everything that we're doing with this runtime defense posture is trying to give you the ability to have very custom tailored application-centric protection for all of the images that compose all of the components of your application, but without you having to go through that and create that manually. This radar view, as I said earlier, is sort of the graphical representation of what that looks like. So from a radar standpoint, what we're doing is saying we know what all these models are, what should be happening in this environment, then we draw that out and dynamically show you what the connectivity is between all those components of the application, such as you can really easily visualize and see what parts work with what other parts, what the connectivity flows are. But more critically is, as we discover that, and as you annotate this by adding your own connections, if there's something that's not expected that needs to be added in there, you can download and synchronize this policy as just a standard Kubernetes networking policy, or a standard policy that can be implemented with whatever sort of networking tool that you might be using in your orchestration plugins. So this works with things like Weave and Calico. And what this does is it allows us to take the knowledge that we have from that model and express that knowledge in a format that can then be consumed by your orchestration's networking plugins to actively enforce layer 2 protections that are application-centric and are automatically updated every time you deploy your application. And again, that's a really fundamentally different thing from the traditional old world model in which, somebody would have had to come here and set up this source to this destination, allow these ports, and as my application changes, those rules rot. Now in this model, we're able to create those rules automatically based on the knowledge of how that application actually is deployed based on those characteristics of the containers that are there. So one of the things when I often show people this YAML file that's generated here is what's missing from this network policy? IP addresses. And the reason IP addresses are missing is, again, in the new world model of security, the IP address is almost irrelevant, right? It's this ephemeral thing that's just the orchestrators assigning dynamically. You're not going to be able to create an IP table rules or use traditional firewalls that are dependent upon specific source destination pairs. You're going to have something that's really container centric in nature. And that's why you can see here the entities, the rules that are being created are saying from what pod to what service over what ports allowed, not what IP address to what destination IP address, because again, the pod is the thing that really matters, not the IP address that might just be a temporary thing at that particular point in time. And so again, the vision that we have and what we're trying to develop for customers and deliver for customers is that notion of leveraging the characteristics of containers to really scale out your application protection, to make it more application-centric and more relevant to the specific apps that you're doing and building, and to do so in a way that's much less manually intensive, really rely on machine learning and automation to build those policies. And I'll leave you with one real-world example. One of our customers is a really well-known entertainment company. They've got a very large deployment of all their properties that they use to serve out trailers and other digital content for their movies and theme parks and so forth. That customer has almost 500 hosts right now that are running in GKE, and those hosts are being used to deliver all kinds of different applications that are out there. They have thousands of images, hundreds of developers that run in that environment. They deploy their application sometimes dozens of times a day because they have so many different teams deploying different things inside of that same environment. And because of the automation we're able to deliver and because of the way that application is built, they're able to do all that stuff with just one security architect. It's the idea with this is to really be able to scale out, to systematize the way that we do the learning, to automate the process of creating the rules, and to be able to create those rules in a way that they're always going to be in sync with the applications that you have because of the integration that we have and leveraging those characteristics of containers. So I'd be happy to take any questions anybody has at this point before we wrap up. No questions at all? Yes? The question is, how is that integrated with Jenkins? So we have plugins for Jenkins and other CI tools so that as you do your builds, we begin not only showing the developer really detailed information about the vulnerabilities and giving them granular ability to fail builds based on CVE state and so forth, but also use that as the opportunity to start learning about the image, right? Because we can see the image there, we can understand what its digest is, and begin doing the static analysis part of that learning right in the CI process before it's ever even pushed to a registry. Other questions? Yes?
When you rebuild the profile, do you use the previous knowledge of the profiles that you had before?
When we rebuild the model, do we use the same knowledge that we had before? We don't. And the reason for that is, number one, it's actually very efficient for us to do it, so it's not a really computationally expensive operation to create the model. But secondly is, it's really hard to reuse knowledge that you already had before without creating false positive situations, because the whole idea is that as you build a new version of that app, there can be many differences between the previous version and the current version. So we don't want to rely on assumptions about the way that it used to work, simply because it happens to have the same tags or labels associated with it. So every time you create an image, we treat that as a distinct entity from the beginning.
You showed an example that's specific to Kubernetes. Does Twistlock work with other orchestration engines like Swarm and Mesos?
Absolutely, yeah. So the question is, do we work with other orchestration engines such as Swarm, DCOS? We do, even sort of, I would call it proprietary, but even like AWS, ECS, the same basic principles apply there as well. The question is, if we detect bad behavior, what can be done from there? There's basically two different things that can be done. One of them, and obviously what most people do with security tools, is you have the option to alert on that. So we emit our audit data through a variety of open approaches. You can actually pull it from us via REST API. We log it through standard RFC syslog, so you can consume it with a SIM and alert on it like that. We also give you the ability, though, to block those. So one of the fundamental things that we do is to give you a policy construct where you can say, if I encounter anomalies at runtime, I want to block and prevent that container from continuing to run and prevent the orchestrator from continuing to deploy it. You can also use that same blocking to enforce whatever vulnerability and compliance rules you have to prevent images that are vulnerable or non-compliant with your standards from ever being deployed in the first place. You can create a rule, for example, that says, if my image or the image that's being attempted to be deployed has a Java vulnerability with a medium severity or higher, prevent that image from being deployed. Or if it contains the CVE for Heartblade, prevent it from being deployed. Or if it runs SSHD or runs as root or whatever it is, you can have these very granular policies that allow you, again, to automate the enforcement of whatever your security standards are across your entire fleet of containers.
What's the impact like on performance?
What's the impact on performance? Great question. We actually, in our most recent release, moved our application from being built around Node to being built on Go, because as we had more and more customers and customers that had more sophisticated scenarios, we're starting to run into some kind of ceiling limitations with Node. So now we have some customers that have, in some cases, 20,000, 25,000 images that that they have, several hundreds or even thousands of hosts that are being maintained. And so typically the performance overhead that we have is on an individual host that we're protecting is usually somewhere less than 1% of one core. And occasionally, if you have lots of images that are being deployed at the same time that need to be scanned, it might go up to 2 to 4% of a single core in the box. And the memory overhead is usually somewhere around 50 megs of consumed memory on the host.
So the static code analysis, does it work on binary or does it also work on a source code?
Static code analysis we do from a variety of things. So we definitely do binary analysis. One of the things that's important about our approach, though, is we also pull vulnerability data from a very wide range of upstream sources, which means that our data is very precise. So we go to Red Hat for Red Hat vulnerabilities, Ubuntu for Ubuntu. We have commercial providers. We cover Ruby and Python and Perl and Java and so forth. And we're looking at that not just at what's existing through the known operating system package managers like RPM and Yum and so forth, but also third-party package managers like NPM and Maven, as well as any sort of application that you've added, just sort of like an add or a copy line in a Docker file of a particular binary. That's where we do the binary analysis for it. So it really doesn't matter so much how you get your application assembled. We try to have coverage for it regardless of what package manager or even just sort of like a raw copy that you do inside of your app. Probably have time for maybe one or two more questions. Anything else? You can. So you can look at the models. We always keep all of the versions of the models available. We do automatic garbage collection after 2 weeks of a model being inactive. But you can always inspect and look at, this version of my app has this setting and this version of my app has this other setting. We also give you the ability, and a lot of customers will do this if they have applications that sort of are corner cases that may not be able to be completely learned comprehensively with machine learning. We have the notion of rules, which are sort of in addition to a model. So a model is always learned by us and is not editable by a customer. And a rule is something where you have exactly the same configuration options there about like what ports and processes and so forth, but you configure it. so that you can create a rule that's very generic that says like apply to any image that's called foo star. So whatever like new version of that I'm going to have, I know that this rule is always going to apply there. And then the way that we calculate what the resultant policy is we take whatever's in that explicit whitelist, the model, we add whatever is explicitly allowed in the rule, and then we subtract whatever is explicitly blocked in the rule. And the result of that calculation is the effective runtime model for that image at runtime. So you really have a lot of control over it. What we've seen from our customers is about 85 to 90% of the images they have are completely handled through machine learning, and obviously we continue to try to improve that. So that the number of places where you have to create rules is typically pretty small, and it typically tends to be things like Jenkins, if you containerize Jenkins, or other things that do a lot of like change as they run, and some of those are very hard to predict in advance. Like with Jenkins, it tends to run lots of different processes, but those processes may only be exercised when you run particular build jobs. And so you can't always predict that at the very beginning definitively everything that it's going to do, and so sometimes you use rules in those cases to supplement the models. Any other questions? Last one, thanks. Well, we got one more. You get Twistlock onto a host you're protecting. You basically have a couple of ways to do that. So everything that we ship is a set of Docker images, so you can just load that into whatever host that you're using. We also are really orchestrator aware, so if you're using Kubernetes, you can deploy Twistlock to our console, our management database and so forth. You can deploy that as a pod and have Kubernetes manage the HA for that. Every one of the nodes that you deploy our Defender container to, you can do with a daemon set. Same thing with like Docker Global Services, DCOS, and same model for all that. And if you want to check out Twistlock, please come by our booth. It's G10. We also have free evals, and we'd love to work with any of you guys. Just twistlock.com. Thanks for your time. Thanks for coming.